Hello students, welcome to EduFarm, Believe and Become, classes for GPAT and NIPER-JEE. If you like, do share our videos, subscribe to our channel and hit the bell icon to never miss any update.
Hello students, here we have a compilation of all the test yourself questions only for your convenience. Each set of 100 questions from test yourself is only for 100 rupees, all in a PDF format. We have got you an offer of 2 question set just for 180 rupees. To avail this offer, you just need to contact us through the mail, and the mail address is edufarm1994@gmail.com. Contact now to avail this offer.
Hello and welcome to today's lecture on PREFORMULATION by EduFarm. This is the second part of the lecture. The link for the first part is given in the cards above as well as in the description below. I will recommend you to watch the first part before beginning. After the lecture, you can ask your questions in the comments below. Let's begin with today's lecture. Now, what is partition coefficient? It is the measurement of drug lipophilicity and indication of its ability to cross cell membranes in oil or water. Partition coefficient in systems such as octanol by water, or it can also be defined as the ratio of un-ionized drug distributed between the organic and aqueous phases at equilibrium. The equation goes like P for partition coefficient in oil by water is equal to concentration in oil divided by concentration in water, which is in equilibrium. When a solute is added to two immiscible liquids, it will distribute itself between the two phases in a fixed ratio, which is referred to as the partition or distribution coefficient. It is independent of concentration of dilute solution of given solute species. Various organic solvents used in determination of partition coefficient include chloroform, ether, amyl acetate, etc. The equation is like P equal to concentration of drug in octanol divided by concentration of drug in water for unionizable drugs, and for ionizable drugs it is P equal to concentration of drug in octanol divided by 1 minus alpha into concentration of drug in water, where alpha is the degree of ionization. If P is greater than 1, it is considered a lipophilic drug, and if P is less than 1, it is considered as a hydrophilic drug. Now, what are the methods in which partition coefficient can be determined? Now, the first one is shake flask method. The drug dissolved in one of the phases is shaken with the other partitioning solvent for 30 minutes, allowed to stand for 5 minutes, and then the majority of the lower aqueous phase is run off and centrifuged for 60 minutes at 2000 rpm. Where the partition coefficient is high, it is usual to reduce the ratio of the drug phase or oil phase from 1:1 to 1:4 or 1:9 in order to increase the aqueous concentration to a measurable level. The second method is the chromatographic method, which includes TLC and HPLC. TLC depends on the separation principle. The separation relies on the relative affinity of the compounds towards both the phases. The compounds in the mobile phase move over the surface of the stationary phase, and the compounds which have higher affinity to the stationary phase move slowly while the other compounds travel fast. The separation principle of HPLC is based on the distribution of the analyte or sample between a mobile phase eluent and a stationary phase packing material of the column. Depending on the chemical structure of the analyte, the molecules are retarded while passing the stationary phase. Now, what is dissolution? Dissolution rate of a drug is only important where it is the rate limiting step in the absorption process. Dissolution is the process in which a substance forms a solution. Dissolution testing measures the extent of the rate of solution formation from a dosage form, such as tablet, capsule, ointment, etc. The dissolution of a drug is important for its bioavailability and therapeutic effectiveness. Intrinsic dissolution rate is when the dissolution is controlled solely by diffusion, that is transport control. The rate of diffusion is directly proportional to the saturated concentration of the drug in solution, that is solubility. The equation goes as follows, where K1 equal to 0.62 d to the power 2/3, V to the power 1/6 and omega to the power 2/3, where V is the kinematic viscosity, omega is the angular velocity of the rotating disk of the drug. Under sink conditions, concentration of saturated phase is many greater than the normal concentration, which gives dC by dt equal to A by V K1 CS. Intrinsic dissolution rate is given by K1 CS. Now what is common ion effect? The suppression of the degree of dissociation of a weak electrolyte by the addition of a strong electrolyte having an ion in common with the weak electrolyte is called the common ion effect. Addition of common ion reduces the solubility of slightly soluble electrolyte. The salting out results from the removal of water molecules as solvent due to completing hydration of the ions. So, weakly basic drugs, which are given as hydrochloric acid salts, have decreased solubility in acidic solution. Example: chlorotetracycline, papaverine, bromhexine, triamterene, etc. The reverse process, which is called salting in, arises with larger anions, that is benzoate and salicylate, which can open the water structure. To identify a common ion interaction, the intrinsic dissolution rate of hydrochloric acid salt should be compared between water and water containing 1.2% W by V NaCl and 0.05 molar HCl and 0.9% NaCl in 0.05 molar HCl. Both saline media contain 0.2 molar chlorine, which is typically encountered in fluids in vivo. Now melting point. Melting point of a drug can be measured using three techniques. The one is capillary melting. Capillary melting, the observation of melting in a capillary tube in a heated metal block, gives information about the melting range, but it is difficult to assign an accurate melting point. In hot stage microscopy, it is the visual observation of melting under a microscope equipped with a heated and lagged sample stage. The heating rate is controllable and up to 3 transitions can be registered. It is more precise as the phase transitions can be registered on a recorder as the melting proceeds, and because of the high magnification, the values are more accurate. Now the third and final one is differential scanning calorimetry and thermal analysis. DTA, or differential thermal analysis, measures the temperature difference between the sample and a reference as a function of temperature or time when heating at a constant rate. DSC, or differential scanning calorimetry, is similar to DTA except that the instrument measures the amount of energy required to keep the sample at the same temperature as the reference. That is, it measures the enthalpy of transition. Now comes polymorphism. Polymorphism. A polymorph. What is a polymorph? A polymorph is a solid material with at least two different molecular arrangements that give distinct crystal species. These differences disappear in the liquid and the vapor state. The highest melting species is generally stable. Other polymorphs are metastable and convert to the stable form. What is pseudopolymorphism? Pseudopolymorphism is the phenomenon wherein a compound is obtained in crystalline forms that differ in the nature of stoichiometry of included solvent molecules. Crystal purity. Thermal analysis has been widely used as a method of purity determination, and the USP includes an appendix describing the methods. Solubility, as discussed earlier also, solubility is a property referring to the ability for a given substance, the solute, to dissolve in a solvent. It is measured in terms of the maximum amount of solute dissolved in a solvent at equilibrium. The resulting solution is called a saturated solution. Now comes the assay development. Assay development is done in 3 stages, namely UV spectroscopy, thin layer chromatography, and high performance liquid chromatography. UV spectroscopy was discussed in the earlier video. I would refer you to watch the earlier video, the part 1 of preformulation. The link is given in the description as well as in the cards above. And as for chromatography, we have discussed in the earlier part of this video only. Now, drug and product stability. Commercial pharmaceutical products should have a shelf life of 3 years. The potency should not fall below 95% under the recommended storage conditions, and the product should still look and perform as it did when first manufactured. Now, drug degradation occurs by 4 main processes, namely hydrolysis, oxidation, photolysis, and trace metal catalysis. Now, what is hydrolysis? Hydrolysis is a common form of chemical reaction where water is mostly used to break down the chemical bonds that exists between a particular substance. What is oxidation? Oxidation is the loss of electrons during a reaction by a molecule, atom, or ion. Oxidation occurs when the oxidation state of the molecule, atom, or ion is increased. Now, what is photolysis? The chemical process by which molecules are broken down into smaller units through the absorption of light is known as photolysis. And finally, the trace metal catalysis. Now, these are the following factors that are responsible for drug and product stability. They are temperature, order of reaction, hydrolysis, influence of pH, solvolysis, oxidation, chelating agents, photolysis, stability, hygroscopicity, stability assessment, etc. Now, what is microscopy? The microscope has 2 pairs of application in pharmaceutical preformulation. One is basic crystallography and the other one is particle size analysis. Now, what is crystal morphology? Crystals are characterized by repetition of atoms, molecules in a regular 3D structure which is absent in glasses and some polymers. There are namely 6 crystal systems: cubic, tetragonal, monoclinic, hexagonal, orthorhombic, and triclinic. These have different internal structures of spatial arrangement. Crystals can adopt different external structures which are tabular, moderate expansion of 2 parallel faces, plates, prismatic columns, acicular, needle-like, and bladed, which is fat or acicular. Although not changing their internal structure, which occurs with the polymorphism, crystals can adopt the different external structures said above. Crystal habits can also be modified by excessive supersaturation, which tends to transform a prism or isodiametric or granular crystals to needle shape. Cooling rate and agitation, which changes habit as it changes the degree of supersaturation. Naphthalene gives thin plates if rapidly recrystallized in cold ethanol or methanol, whereas slow evaporation yields prisms. The crystallizing solvent affects habit by preferential absorption on the certain phases, inhibiting their growth. Resorcinol produces needles from benzene and squat prisms from butyl acetate. And the final one, addition of co-solvents. The addition of co-solvents or other solvents and ions which can habit by poisoning crystals growth in one or more directions. Sodium chloride is usually cubic, but urea produces an octahedral habit. Now particle size analysis. Small particles are particularly important in low-dose, high-potency drug candidates as large particles. Populations are necessary to ensure adequate blend homogeneity and for many drugs whose aqueous solubility is poor. As dissolution rate is directly proportional to the surface area, there are numerous methods for particle sizing. The first one is sieving, the second one is the microscope counting technique, and the third and final one is the Coulter counter method. That's all for today. Check more of our videos and let us know of any query in the comment section below. Also, you can suggest topics for our next video. You can also support us. Check the description for details. Your support will encourage us to make more such videos. Thanks for watching. Hope to see you in our next lecture. Till then, keep your preparations on with EduFarm.